My name is Nassim Haramein. Thanks for coming, all of you. We've got people from everywhere. Portland, Ashland, Reno, all the way from Reno. It's great. Thank you all for being here. So, today we have a big day. A lot of information is gonna flow through this room today, and we're gonna go through all the physics from universal size object right down to subatomic particle, going through consciousness, ancient civilization, chemistry, biology, and so on. So we've got a big agenda. It's going to be fun. And it's going to take a little time. So be comfortable. Make sure you are comfortable. Make sure you have enough water to lubricate your brain. Lubrication. And make sure that if you have to that you eat enough and all this, so your blood sugar doesn't drop too far. Sometimes I see people, I see smoke starting to come out of the ears. Then I know there's like damage being done. So we'll try to avoid that today. Oh, okay. Maybe we can turn that down on the board. Which one is that? That one there? Low. Okay. Is that better? Yeah. Good. I've been having a little bit of trouble with my throat, so usually I just project, but today I'm going to try to be nice to my voice. Yeah. Get good lubrication going. So, go ahead.
What's the break schedule?
The break schedule is when I see everybody's turning purple because they have to go to the washroom and stuff, then I'll stop. Actually, if you guys are really exhausted and you need a break, just let me know, because I just keep on going. I just go and go for like 13 hours. So, sometimes I forget about the crowd. And so, oops. So, but in general, I'm going to try to break around 1 o'clock or 12:30. And then we'll reconvene for a little more, and then we'll have lunch around 2, and then come back, and then I have the evening sessions. We might be here for a while. So, I was asked to present a bunch of different things today that I usually don't have time to present, so I'm going to try to squeeze it in. So especially a section on the Knights Templar that I usually don't present. So I'm going to talk real fast. One thing that happens is that when I'm presenting this information, there's a certain amount of complexity. Although the concepts are really simple and you're going to get them right away, there's a certain amount of complexity. There's a certain amount of rewiring that occurs from things that you've been taught and from just a new way of thinking coming in, and that takes a little bit of time. And what happens is that if you have too many questions that are unanswered, then it starts piling up, and that's when I start noticing people turning white, and it's like, oh my God, they're gonna explode. And so because it makes like a dam of all the things that are not figured out. So I'm going to allow you to interrupt me and ask questions, but it's gonna have to be like really, really crucial for you to interrupt me and ask questions. Otherwise, I just get interrupted too much and it breaks the flow and it's really hard to get all the information in. So before you ask questions, please think about it or see if I'm going to answer that question shortly after, because commonly that happens. But if it's really piling up and you just cannot go forward in the thinking without getting those questions answered, please just interrupt me. You can start screaming, jump up and down or something. I'll get the signal. So I'm going to go through the information today in a little bit of a chronological way. How I came up with it and how it changed my life and how my life evolved as the information evolved. And you'll see that although this information can get extremely complex, extremely fast, the way I learned about it, the way I learned it, makes it easy because it was just a series of logical progression that I teach typically to even 7 years old. And actually, some of the 7 or older kids commonly after the talks come up to me and say, "Are you sure the other physicists don't think this way?" And I'm like, I really checked it out. I spent 20 years checking it out. They really don't think this way. And it boggles their mind because it's kind of obvious and it's kind of instinctive. It's not kind of instinctive, it's instinctive. And it's a funny thing that like commonly now, they think of these thoughts as counter-instinctive. But I think they're quite instinctive. And they got counter-instinctive as a result of confusion. In the early ages, when we learned some of the foundations of our reality at school. So that's really what happened. At the age of 7, I had a bunch of esoteric experiences. And we're not going to get into that, but I had an intuition, and I definitely had experiences that told me that there was something else than the reality we observe. That like the reality we observe is just like a little bitty part of what's going on. Just like if you'd like the electromagnetic spectrum has a section that we see, and then there's a whole bunch we don't see. And the part that we don't see has huge impact on the physics of the part that we see. And I felt that very early, until they discovered, for instance, X-ray and infrared and long wavelengths and so on. They thought that all there was the visible spectrum. And, it became clear later on that there wasn't, that there was much more. And I think that it's becoming clear now in current physics that there is a whole bunch of stuff going on that we're not aware of that is actually generating the part that we are aware of. So when I was 7, I noticed this. I had experience that made me notice this. So when I got to the age of 10 and I got into my first geometry class, and the teacher went to the blackboard and said, "Today we're going to learn about dimensions," I thought, that's it. Oh my God, finally somebody's going to explain to me what's this other world about. These other dimensions that I felt were present. And I got really excited. I was like, oh my God, finally an adult that's going to talk about something real, and something that makes sense to me. So the teacher started the lesson and I got really, really disappointed. He didn't tell me anything about the dimensions that I was experiencing earlier on in my life. But he actually gave me one of the major keys to the evolution of this theory and to its conclusion and into its proof that is now being peer-reviewed in many universities around the U.S. and from scientists that are looking at it from NASA and so on. So it's really exciting. And that, at the age of 10, made a huge difference. What the teacher did is he went to the blackboard, and we'll call this our blackboard today, and he made a dot. And he said, the dot is dimension 0, and it doesn't exist. And I went, okay, I can see it, but it doesn't exist. And, I was near the door in the back of the room. I was always closest to the door because I was having so much problems at school. And, I'm like, okay, whatever, if you got a dot that doesn't exist, I can go with that for now. And then he said, this is a series of dots that he placed together and made a line and said this is dimension 1 and it doesn't exist either. It still doesn't have volume. And, that seems consistent to me. Then he placed a bunch of lines that are made out of dots together, made a plane, called it 2D, and said this is the dimension that that your comic strips lives in. It still doesn't exist. It still doesn't have volume. Well, until then, although, it was kind of a bizarre approach, it was consistent. But then he did something that seemed like a miracle. He grabbed 6 of these planes and put them together on the blackboard, made a cube, and said, this is dimension 3, 3D, that one you exist in. And I was in the back of the room, and I'm like, oh my God, how can that be? And I could tell that all the other kids in the room were like, huh? But nobody was saying anything. I wasn't about to put my hand up because I knew the next thing that was going to happen is the door was going to get open and I was going to get kicked out again. So I didn't want to do that. So I didn't say anything, but it didn't make sense because it's like that was a mystery cube. Because if you have a dot that doesn't exist, that makes a line that doesn't exist, that makes a plane that doesn't exist. You slap 6 non-existing planes together, you don't get existence. All you get is non-existence to the 4th. Okay? It's got nothing to do with existence. You just have got a bunch of non-existing dots together, so nothing exists. And that was not logical. And I have a tendency to be an extremely logical human being. And it turns out that Buckminster Fuller, I found out later, had the same problem at school. He wrote about it in his book. And he didn't understand how this worked neither, and he didn't thought it was correct. And actually, through my research, I found that this is an ancient riddle. It's mentioned in ancient manuscripts that are from the Middle East and so on, and there is all sorts of treaties about this problem, although this problem is the foundation of our understanding of physics and dimensions. And all of our knowledge is actually based on it. And it creates a lot of problems. This simple riddle that is unsolved has generated a whole set of distortion in our societies and in the way we do physics and the way we understand the universe and how we relate to it. And we're going to see that today. We're going to see this error just come back and bite us in the butt every time we come around the corner. You all following this?
Yeah.
Well, okay. Well, I was going home from my school that night, and I had an hour and a half bus ride back home. And that's because I kept on getting kicked out of the schools closest to my home. So I had to go further and further, and some physicists once told me, actually, I was furthering my education that way. And I thought that was true because I had all this time to think when I was in the bus. So I was thinking, and I was going in this bus, and I'm like, I'm not living another day without solving this. I had no idea that nobody had been able to solve this or anything like that. Nobody told me it was not solvable. Nobody told me I shouldn't be working on this when I was 10. So I was in my bus going, I cannot survive another day on this planet without knowing what the heck a dimension is. And what is this dimension I'm in? And what are these other dimensions I'm experiencing, or these other energies I'm experiencing, and so on. So I'm thinking, and I'm thinking, and I'm thinking, and I've got a goal in my head that I'm going to solve this before I get off the bus. So the bus is getting crowdier, and it's like more and more people in there, and it's getting really kind of tight. I'm like sitting on this little bench, and I'm getting squashed, and I'm getting really uncomfortable, and I'm trying to think about all this, and I'm like, I got to find a solution. And at one point I thought, well, maybe I should like try to get my mind out of this bus because it's just getting too crowded in here. So I started to expand my mind, and I rose above the bus, and I saw, in my mind's eye, I saw the bus becoming a dot. And then I rose further, and I saw the Earth becoming a dot. And I rose further, I saw the solar system becoming a dot. And I rose further, and I saw the galaxy becoming a dot. And then I flew back into the galaxy, into the solar system, and back into the I saw the Earth, and then I saw the bus, and I found the bus, and flew back into my body. And I thought, wow. And I looked at my hand, and I flew into my hand in my mind's eye, and I saw it was made out of dots. I didn't know those were called cells, And then I flew into one of the cells in my mind's eye, and I saw that cell had to be made of thousands of little dots we call atoms. And I flew into, actually, billions of little dots we call atoms. And then I flew into one of those dots, and I saw that inside the atom there was a whole bunch of other dots in the middle, and so on. And actually, that was my first glimpse at the fractal nature of the universe. And I thought, oh my God, I know how to solve this. It's a dot within a dot within a dot to infinity. And the only thing that exists is the dot. Within each point, all information is available. Each point contains the whole. So the only true existence is the point. And from that point, or from an arrangement of points, you get all of reality. Wow. I was onto something. I got really excited. That's the way it goes. Each point contains the whole. Each point has all information. Each point is connected to all other points in the universe. And then the universe arranges the points in all sorts of different ways and makes all of the things we see. Well, that would mean that each point had to contain infinite amount of energy, infinite amount of information. Well, I got excited, and I'm like, oh my God, I got to tell my mom. So I went back home, I got out of the bus, and I'm all excited. I'm like walking on the cloud. I'm feeling like I've got this illumination, and I'm on my way to changing the world and all this, and I get home and I wait for my mom. My mom comes back from work, and I'm like, "Oh, Mom, I figured out something at school today. It's real important." She smiles and she's like, "Oh my God, he finally had an A in a test or something. She thought I did something real good at school." And I'm like, "Mom, I figured out that each point contains the whole. Each part of you has infinite involved in it, and each point has a connection to everything else." And I'm telling her all that, and she looked at me and she, "Part of your curriculum at school, is it? And I think you should go back to it. You're not doing." And and my mom's kind of a pragmatic person, and she's a Roman Italian, woman, and she just looked at me and said, "Anyway, today I don't feel infinite." I'm not feeling infinite, so why don't you just go back to your curriculum, Go do your homework or something. And at time I got disappointed. It crushed me. I was like, "Oh my God, she's right. How can a point contain the whole if a point has a finite boundary? If the body has a finite boundary, how can it have infinity in it?" So I was like, "Oh, I gotta go back to the drawing. How do I do this?" Well, it turns out that that's gotta be one of the largest errors that is going on in our understanding of physics and our understanding of the way the universe functions and our place in it. That is, that infinity and finite system are opposites instead of complementary. But how can a finite system and an infinite curvature be complementary? How can the two be together? I knew when I was 10 that there was a solution to this, because I knew I was right, because I had seen it in my mind's eye. I instinctively knew it. Actually, most children I talk to, if they haven't gone through that first lesson of geometry, know this. They think of the universe as infinitely big and infinitely small, all embedded into each other to infinity. In general, they think of that as being quite logical. The kids are not the only people that thought of this. Do we have sound on the computer? One famous physicist, Carl Sagan, wrote a book called Contact. And then there was a movie that was made out of that book. And the movie starts like this. Thank you. Okay, this is a little bit hard to see. It's the edge of the Earth. There we go. And so we're moving away from the Earth in space. And as we move out, we catch up with all the radio waves that were sent into space by the Earth. So it's like almost going back in time. There goes Saturn. exiting our solar system. And shortly we'll be exiting the arm of the galaxy we're in. Here's our galaxy center. Now we're moving faster and faster away from our galactic supercluster. So the concept of a universe within a point, was there quite definitely described. Let me tell you as well that the concept of a universe coming out of a dot is not that outrageous. The current theory of the Big Bang says that we all came out of an all of our universe. The only difference here is that this view says, no, it didn't all emerge from one dot that decided to make a universe. All dots contain the possibility of a universe in it. All dots are connected to all other dots. And so here, then Hollywood came up with their version of this concept. And since they're the man in black, they have much faster technology. They can move much faster than anybody else. So that's the end of Man in Black movie. They have extreme speed. Because they got all that alien technology. Little marbles we are. So these concepts have been around, except they've never really been understood because, again, how do you fit infinity in a finite space? And it's crucial that we understand how we did it. Well, when I grew up, eventually, I found the solution. I found the answer to this. The solution is what is called a fractal. And I'm going to show you very, very simply how infinity fits into finite. How infinity and finite systems are absolutely complementary. And that each point has the potential of having all information in it. I'm going to show you this in a geometrical way. So it's really easy to understand. And it just happens that the way I'm showing you this turns out to be very crucial to the way systems are organized and generate the geometry of our reality. everywhere we live. So we're going to make a boundary, a circle, and inside it we're going to inscribe a tetrahedron, or an equilateral triangle in this case. The boundary could be a sphere, and the middle triangle could be a tetrahedron. Okay? So this you can visualize in 3D space, in spherical coordinates. Now, the universe is polarized, positive, negative, male, female, white and black. So this has a polarity, right? And generates a reverse equilateral triangle. Now, I'll give you a hint to the ancient civilization part of this lecture we're going to have today. Right away, we have one of the most commonly found symbols in all ancient civilization around the world. A circle with a double triangular polarity inside it, commonly referred as the Star of David, or the Shield of Solomon, the Star of Zion. It's found on many walls around the world of ancient civilization. Now, if you keep adding triangles, you get smaller stars, smaller stars of David. And then you can keep adding them again, and you get smaller stars again. Now, at each level of the fractal, you're going to generate a boundary. This is an important part to understand. Each level generates a boundary. Again, boundaries at the next level. And now I'm making smaller boundaries. See, I didn't put them all around because I got lazy. And then now I'm making smaller boundaries again. And smaller, and now they're so small you can't see it. Now, if I give that equation to my computer and got the computer to just keep making boundaries, keep making smaller and smaller triangles, it would continue to do this to infinity until it heated up, melt down, and I'd have to go and get myself a new computer. But assuming it didn't do that, it would keep making smaller and smaller triangles to infinity. And I could give it a code so that every 5 iteration or 6 iteration, it would zoom in so you could see it again, and then starts making more triangles, and then zoom in, and then so on to infinity. However, although I can place an infinite amount of triangles, I will never exceed the first boundary I made for myself. Never. I just showed you how infinity fits in a finite space, or a so-called finite space. Because you can divide to infinity within the circumference of a circle. What does that mean? Why is that important? What does that do to your life? What does that do to the way we do things on this planet? Well, let me give you an example, even if it's just for physics. We built faster and faster and faster accelerators that cost billions of dollars to build, to get smaller and smaller and smaller and smaller. Now we're at like millions of times smaller than an atom particle, actually. And we're building accelerators now in Geneva, in Switzerland, that are costing $300 billion, I believe. 5 countries had to get together to build it, right? To get even smaller particles. Well, if we understand this principle, we would understand very quickly that you can keep building larger accelerators and you can keep getting smaller and smaller particles, you can always keep dividing. So we would give up the search for some fundamental particle and that's going to end the search for particles, and we would start to understand that what we need to discover is the dynamics of the division, the dynamics of the quantization. You understand? Not, how far we can go into infinity. Just so that some physicist can put his name on it and get a Nobel Prize for a new particle. But further, what does it mean to you? It means that if this is true, every one of your atoms, every one of your cells has infinite potential in it, has infinite connectivity to everything else. That each one of your atoms is a mini black hole. Because if there's infinite amount of particles in it that can be divided, that means it has infinite mass. Most people say, I can't envision infinity. If, it's a good point. You might have to take a lot of coffee in the morning. But it's like, I can't visualize infinity. If it's true that I have an infinite nature inside of me, how is it that I can't see it, that I can't visualize it? That's a good point. Well, the reason is that most people try to envision infinitely large when they think of infinity. So that is limited by your senses because it's external to you. However, here we see that through infinite division we can generate singularity, a link to all other things. So when you try to visualize infinity, you might want to turn your senses inwards and go towards the infinitely small that's contained in all of your atoms, in all of your cells. Well, it just happens that all of the masters that have walked the earth have been trying to tell people about turning their senses inward through meditation, prayers, and so on, to connect with their infinite nature. The Buddha, Jesus, all these people said the temple of heaven is within you and within everything. That's the description of a fractal, my friend. The thing is that it was never appropriately applied to physics. It has huge repercussions in physics because it completely changes the way we look at the structure of reality if everything contains the whole. So you see, already this is a key to understanding your nature and your potential. How many times in the year do you turn your senses inward and connect with your infinite nature? And so I was really excited about this because it seemed to say as well that the universe would be expanding and contracting. Right? If everything goes towards infinity, at the center of all atoms, then the universe is contracting as much as it expands. And I could see how the external part of my existence is the expansive part, and the internal part of my existence is the contractive part. So I started to think in those terms when I was actually 11. And I learned to meditate. A young master of meditation from India taught me to meditate. And I was really excited because I was discovering a whole world within myself that seemed to have infinite potential. So I started to spend more and more time concentrating inward and connecting with that part of my existence. And I started to think that there must be a balance between the expansion of the universe and the contraction of the universe. And the contractive part of that balance equation is the part that generates. And the radiating part is the part that alienates, that destroys. Yet, all of our science, all of our knowledge is based on the radiating part. There's nothing we've really discovered since fire. We explode everything. We put fuel in a rocket, right? Tons and tons of fuel, and we light the bottom, put a few people on top, and pray that they're going to survive the experience. That's our approach. We put fuel in our car, and we explode it in a chamber, and we push a piston up and down. It's all about explosion. And we think the universe is expanding.